our lecture, we are going to look at analytical chemistry, and we want to look at what analytical chemistry, what do they really do? Analytical chemistry can be viewed in terms of the classical or traditional method of analysis, or we look at the modern or instrumentation way of analysis. When you talk of the classical or traditional way of analysis, you are also talking of things like wet chemistry, in which solutions are formed, in which physical and chemical parameters of matter are investigated. What do analytical chemists, what do they really do? What analytical chemists do is that they tend to analyze sample in details. That is methodological analysis of sample. Apart from analyzing sample, they also tend to improve on the previous or the traditional method of analysis. So analytical chemistry is all about analyzing materials. I think in materials can be classified as, that is matter, can be classified as solid, liquid, gases, and plasma. So analytical chemistry is that branch of chemistry that tends to study all these materials in details. You study them in details. Studying them, analyzing them can be in two formats. It can be in form of qualitative analysis. It can also be in form of quantitative analysis. If you talk of qualitative analysis, what do? You tend to find out what that material or analyte is made up of. What is in that material? What is the make of that material? If you are not concerned about the quantity of such make, all what you want to know is what make up that solid, what make up that liquid, what make up that gases. But in the case of quantitative, this time around you want to know the quantity. That is from the name, quantity. This time around you are concerned with analysis like concentration. You are concerned with analysis like determining mass. You are concerned with analysis like finding out intensity of the material that make up the substance that make up your material. Now we said analytical chemistry is divided into traditional or classical analysis, method of analysis, and we also have our modern or instrumentation method of analysis. All what analysis entail is all about you first of all try as much as possible to obtain your sample. That is what is known as sampling. You obtain your sample from the gross sample, from the bulk sample, from the site sample. You obtain your sample, and the sample that an analyst is mostly interested on is the laboratory sample. And that laboratory sample is a total representation of your gross sample, your bulk sample, your all of the population. The little you are going to use, that is the laboratory sample, should be able to be the to serve as a total representation of the bulk sample. It doesn't really, you don't have to carry the whole bulk to your laboratory for analysis. The little you are going to use must be representative of the bulk sample. Now, apart from that, you have to look at how you are going to extract these samples. How do you extract what you intend to analyze? Apart from extracting, you have to do what is known as separation. You have to separate the samples from your analyte, from the other constituents that make up that sample. You have to isolate, you have to identify, and you have to characterize. These are all stages in analytical chemistry. However, the beauty about the modern or instrumentation type of analysis is that all these processes can be worked on by your machine simultaneously. All these processes can be executed simultaneously by your machine, and that is why using machine you tend to reduce error. You tend to reduce error. You tend to reduce error that can come from human deficiency, and at the same time you tend to increase speed. You tend to increase speed. You tend to increase reliability of the result you obtain. These are some of the advantages of using modern or applying modern or instrumental type of chemical analysis. Now we said analysis is all about determining detailed determination of your sample. Apart from you determine either the qualitative or the quantitative aspect of it, the analytical chemistry can also give us a clue on how we can improve. On the existing method of analysis. How we can improve on the existing method of analysis. This analytical chemistry, are they really important? Are they versatile? Of course, they are versatile. And when you look at, you'll find analytical chemists everywhere. In engineering, they are there. In medicine, they are there. And pharmaceutical companies, pharmaceutical organizations, they are there. In forensic, you'll find them in forensic, agriculture, they are there. This wide application of analytical chemistry. It's something that if you want quality, you have to imbibe and invite the analytical chemist, the analytical scientist to get the job done for you. In engineering, you have to complement the work of structural engineers. In medicine, you have to know the drug, the blood serum you are going to apply. In pharmaceutical organization, producing drugs, you have to really use a chemical an analytical chemist to do your analysis for you, so that you end up producing a quality drug. The forensic, these are specially trained analysts, in which they are dependable in when you talk of crime scene. Their importance cannot be overemphasized. And agriculture, the type of soil we use, the pH of the soil, and its effect on the growth of plants. These are just areas that are very, very important, which analytical chemists can comfortably fit in. There are things we need to understand. What analytical chemists, what they do over the years is to see how they are going to improve on existing system, existing method of analysis, and that is why the instrumentation or the modern method of analytical chemistry chose to creep in tactically, or it chose to creep in just to complement our classical or traditional method of analyzing material. Instrumentation. Here you use all manner of tools, all manner of machine to get the work done for you. What do they do? The sample in question interacts with either electromagnetic radiation, either heat, either light, to analyze the sample and get you the result. Here they do all this, they separate. When you talk of instrumentation, you tend to look at the sample and their interaction with electromagnetic radiation, interaction with heat, that is during using our calorimetry. You look at light. Let us look at some of the machines. Most of these machines, what they do all these things at the same time simultaneously. They do the isolation, they do the separation, they do the identification, and they characterize and they furnish you with the results. Let us look at some of these machines. Let us just look at some of these machines. Possibly in our subsequent lecture, we will take their working into consideration. One of them is our FTIR full transform infrared spectroscopy, our UV visible spectroscopy, our NMR, nuclear magnetic resonance spectroscopy. Sometimes we combine our mass spec, that is our GC, gas chromatography, and mass GCMS spectroscopy. We have our X-ray crystallography. We have our HPLC, high performance liquid chromatography. These are all machines that tend to help us in our various analysis. In my subsequent lecture, we'll tend to take each of these machines and we'll really see what do they really work on. But the machine, what do the machine do? They help us to obtain a more accurate result in jiffy, depending on the user, the operator of this machine. Now, it didn't really stop there. We have our chemometrics. Chemometrics is the application of mathematics or statistics in interpreting chemical analysis. This is a new branch of analytical chemistry that tends to study the results obtained from our analysis. And in the process, we can project, we can forecast. We can project, we can forecast from the various analysis with the help of mathematics or statistics. We are looking forward to your subscribing to my channel, which is Adamu Salahuddin YouTube channel for more of my lectures on chemistry. Thank you for listening.